Welcome to 6-Minute Statistics. In this video, I'm going to take a deeper dive into the cumulative normal probability tables. You should have already watched my introduction to normal distributions, and what you've learned is that there are two main types of tables to work with. The cumulative, which I'm going to cover here, and the inside probability table that I'm going to take a look at in a different video. While I'm going to be looking at tables in this video, it's important to note that the principles that I go over will apply to whether you're getting cumulative probabilities from a table or a computer software program. The key is knowing what to do with them and how to work with the probabilities that we find. Are you ready? All right, let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Mark here from 6-Minute Statistics, and you might notice I'm still sporting my normal probability shirt. Unfortunately, while it has something to do with normal distributions, it really doesn't apply all that well to cumulative probabilities. If you take a look at the probabilities covered in this shirt, they're more on the inside. We want to look at, in this video at least, cumulative probabilities. What's that mean? Great question. Why are you wearing that t-shirt? Another good question. Well, I'm looking for opportunities to wear normal shirts. There's just not a lot of them. And secondly, it may or may not be my only clean shirt. I got a million of them. All right, let's begin our conversation of cumulative probabilities. Let's take a look at the cumulative table. There are actually a couple different forms of the table, but I'm going to provide the longer form here. Notice how I have to scroll through the many rows of information contained in the table? Relax and breathe. I'm going to be explaining it all to you in this video. The table has two main parts. The outside row and first column of the table provide the z value. These are points in the distribution that fall on the x-axis underneath the curve. Notice how the z values are given to two decimal places. We find the first decimal place along the left-hand column in the table, and then we go across that top row to find the second decimal place. As an example, if I'm interested in working with the z-score or z-value of 1.05, I scroll down that first column until I run into the value of 1.00. Then I work my way across the top row until I get to the 0.05 column. Matching the 1.00 up with the 0.05 will provide me with the z-value of 1.05. So that's the z-score. We notice some of them are negative, some of them are positive. The second part of the table are the 4-digit decimals located in the main body of the table. We use those as the cumulative probabilities for the z-score we look up. For instance, if I match up that 1.00 row with the 0.05 column, we see the probability of 0.8531. That is the cumulative probability less than or equal to 1.05. In a nutshell, that's how it works. Cumulative probabilities will be easy to find. The challenge is, of course, I'm not always going to ask you to find less than or equal to probabilities. What if I want you to look at a greater than probability? How about the probability between two z-values? Well, we can use cumulative probabilities, but we have to get clever with them. Let's take a look at an example, and I'll show you how to do this. Let's assume we're working with a standard normal distribution, and we want to find the following probabilities. First, the probability z is less than 1.23. Second, the probability z is greater than 1.23. And finally, the probability that z is between a negative 0.25 and a positive 0.55. Let's start with the easy one. The probability z is less than 1.23. For the normal curve, the probability z is less than 1.23 is exactly the same as the probability z is less than or equal to. It's a cumulative probability. So we go down that first column until we get to the 1.20 row, and then we go across that first row until we get to the 0.03 column. I think I said that right. So matching the 1.20 and the 0.03 gives us a z-value of 1.23. Notice the probability in the square where they match up is 0.8907. That's the probability z is less than 1.23. The second probability I asked for was the probability z is greater than 1.23. Think of the picture that we have over here in the less than or equal to shading. What's the greater than shading look like? It's the other part of the curve. Now, what we know about normal distributions is the total area under the curve, or the total probability, has to be 1. So if that less than or equal to probability is 0.8907, the greater than probability, which I could also say is the greater than or equal to probability, is 1 minus that. 1 minus 0.8907 in this case is 0.1093, and that's the probability Z is greater than 1.23. All right, that's the less than probability. And the greater than probability, how about the between probability? What's the probability the standard normal random variable Z falls between a negative 0.25 and a positive 0.55? Well, how are we going to use the cumulative probability table for this? What we can find is the probability less than and equal to the negative 0.25. We find the negative 0.20 row in the table, the 0.05 column, matching them up, we see a cumulative probability of 0.4013. I'll shade that in my table or in my picture. Likewise, I'll find the cumulative probability for the Z-value of 0.55 by going to a 0.50 row, and again, the 0.05 column. Matching that up, we see a cumulative probability for that Z-score, 0.7088. I want between. What do I have to do with these two probabilities? Well, this reminds me a lot of the binomial tables that we looked at. We're going to subtract those two probabilities. To find the probability between the Z-value of negative 0.25 and a positive 0.55, we simply subtract the 0.7088 minus the 0.4013, and the part we're left with, 0.3075, is the probability between. And that's how it works. Your job right now, if you're watching this video, is to work on cumulative probabilities. Take a look at some examples, find probabilities that are above, between, below, and make sure you are a cumulative table wizard. Wow, wizard, that sounds like fun. Well, maybe not, but it's time for you to get to work anyway. I'll talk to you later. So long.